In this video, I'd like to look at while loops and for loops in Wolfram Cloud or Mathematica. And so loops are for repeating something. So the thing I'm going to repeat is just to grab a random number. And so I will use the random choice method here. So first I'm just going to show you the random choice method, and then I will start to put it inside a loop. So random choice is going to pick something from a range, from a set of things, and then I happen to assign it a value of p, which doesn't do me much here. It'll be a little bit more useful a little bit later, but let me enter this, shift enter, and I got a 2, I got a 3, I got a 1, I got another 1, got a 3, I got an 8. Okay, so I'm getting random numbers between 1 and 10 inclusive. Okay, so that's what random choice does. Okay. Now let's begin with the while loop. So a standard while loop is that there is the keyword while, some condition that you're testing, and while that condition is true, some set of statements you want to do while the condition remains true. And there may be things you want to do before or after the loop in order to either set up the loop or to, maybe finish off something or display something when the loop is done. Okay, so so here's the main while notation. And the while, this looks complicated because I'm doing a couple of things here. But the main structure is that while consists of two parts: the condition and what you want to do under the circumstance that the condition remains true. So I have some variable p that I want to be greater than 2. And so long as p remains greater than 2, I'm going to perform these statements and then test again. And if the test is still true, then perform them again. I wanted to at least be in this loop once. So before I get into the loop, I set p to 10, and p10 is greater than 2. So I'm going to get in this loop at least the first time. And I'm going to work with a counter that I called I. So I initialized I to a value of 1. So those were done before the for loop, and I have separated my statements with semicolons. The two parts of a while, and this is how Mathematica handles it, there are two aspects of a while: the condition and what you want to do. And then what you want to do can be a sequence of statements. So the condition and the statements are separated by a comma. They're the two parts of a method. And so you usually use a comma to separate things of a method. So the while is a method here. It's a little bit different philosophy than sort of what you see in most programming languages, but the while is a method, and it has arguments, and the first argument is the condition, and then a comma, and then the second argument is a set of statements, and those statements are separated by semicolons. So it takes a little getting used to that notation, at least that did for me. And so here initially I set p equal to 10, so I'll get in the loop. I set I equal to 1 to start my count. That's my counter, and I'm initializing my counter at 1. I have my while method. It has two parts. The condition, p being greater than 2, is the condition under which I will continue. And then I'm getting a new p as a random number, and that's why I'm using a while loop. Though the standard thing for a while is that you don't know how many times you're going to do it. You have while loops and for loops. When you know how many times you want to repeat, you tend to use a for loop. When you don't know, you tend to use a while. It can be used interchangeably, but that's usually the sort of natural distinction that you want between the two. And so I'm getting a new, so in the second argument, the statement part of the while loop, I'm getting a new p randomly, between 1 and 10. I am printing something and I'm incrementing my counter. And you can see, let's run that, shift enter. There is, that time it took like 8 iterations to get out of the loop, but I can run it again. And this time it took 4, and you see if this last value is a 1 or a 2, then the condition is false and we get out of the loop. So there it took much longer time. It took 16 iterations to get a 2 and get us out of that loop. Okay. And now so this was just to increment the counter I, so that's why I was 1, 2, 3. And here is the p with its different values. And finally, when it was 2, that got us out of the loop. And then we just need to look at this print statement. So there are a couple of different ways to print, but this is one of them. We are printing something out to the environment. We are forming a string, and then the tick mark indicates something that is a variable. So I have quotes. So I have what I would at least normally call a literal, but the tick mark indicates something that's not strictly speaking literal, but that I'm going to put a variable into, and I'm putting tick mark 1 and tick mark 2, sort of saying that after I've done my quote, that I'm going to say what I want in position where I show 1 is I, and then when I show what I have in 2 is the p. So I'm just giving my counter, a period, a space, and then the random number. So that's just a way to print. Okay, so this was my while loop. Again, in Mathematica, Wolfram Cloud, the while is a method. It has sort of 2 arguments, a condition, and then the second argument is statements, and there can be more than one statement. So then the statements are separated by semicolons. Okay, now let's look at a for loop. So a normal for loop is going, again, it's in Mathematica, Wolfram Cloud. It is a method, and it has 4 arguments. And in a for loop, you normally know how many times you're going to be in the loop, and you're often using some kind of counter. And so I'm going to be in this loop 10 times. I'm starting a counter at 1. I am staying in the loop under the condition that my counter I is less than or equal to 10. And then I am incrementing my counter by I. So that's there are going to be 4 parts of the for method. An initialization of some counter. In this case, I started my counter at 1. Some condition in which I remain in the for loop, and then the way in which I am changing my counter, the way in which I'm incrementing or could be decrementing. And this is just the simplest one, sort of going up by ones, but it's flexible. It didn't have to start at one. It didn't have to go up by ones. So you can play a lot of games with these three arguments. And then the fourth argument in the for method, in Mathematica's for method, is again statements. And if there's more than one statement, it is separated by semicolons. So again, I'm in this case choosing P. In this case, it doesn't affect how many times I'm in the loop as it did in the while loop, but I'm still getting a random number and then printing it out. So, and in a for loop, the counting is built into the first part, whereas in the while loop, the incrementing was part of the second argument, part of the set of statements. In the for loop, the counting is built into the first three arguments, so I don't need to increment explicitly in the fourth argument because I'm already doing it in, well, I'm incrementing in the third argument here. So I don't have to do it again in the fourth, or it would be redundant. I would be over incrementing. But I'm grabbing a random number, and then I am printing it out, and I'm using the same printing technique as before. StringForm, that's a method that has, in this case, a first, the first argument is something quasi-literal, I'll call it, with some tick marks indicating positions 1 and 2, and the first thing after the second argument, or the first thing after the first argument, replaces 1 in the tick marks, and the second thing after the quotation marks replaces the 2. And so that was from my previous run. Let me shift enter, and we're getting 10 random numbers. We're always getting 10 random numbers in this one. It's a for loop, and so we expect it to always be the same number of times. Okay. In this one that I'm doing now, it's the same for loop, 1 less than or equal I equals 1, I less than or equal 10, I plus plus. That's the same loop that repeats 10 times. I'm still picking a random number between 1 and 10. And this 10 and that 10 are just a fluke, or just I happen to have 10 fingers or something. It's those two things don't have to be the same at all. That's got nothing to do with it. But what this one is showing is just a different way to print. So I am concatenating a bunch of things together in my print statement. That's what this sort of less than greater thing does. It sort of glues things together. And then I have to say that my I and my P are not normal things that I print, are not strings, but I use this ToString method to convert them. So I'm converting my I to a string, and then I'm sort of gluing it to a period and a space, and then I'm gluing that to my P, represented, turned into a string, cast as a string. So it's doing the same thing. I'm just showing you an alternative for printing. Okay. So that was the reason for the second one. In this last one, what I am doing is, again, I'm going to have a for loop. I'm going to be in the for loop for 10 iterations, but instead of printing out 10 random numbers, I'm going to add those 10 random numbers to a list and then print out the list. Okay, so I'm starting off my initialization before my for loop is to get things started, is I'm introducing a list, sort of an empty list, and I'm calling it my list. So this is just an assignment saying I'm going to have a list. It's starting off empty. And the for loop is a Mathematica method. It has 4 arguments: initialize the counter, the condition to continue in the loop, the how I'm incrementing. I'm starting at 1, I'm going up to and including 10, I'm incrementing by 1s, and then the 4th argument is some set of statements separated by semicolons. One more time, getting the random number between 1 and 10 inclusive. And here I am taking that random number and appending it to the list. And so my print is not in my loop. When I'm done my loop, then I do something after the loop is done, and I am printing out my list. And so you see the curly brackets here. And so Shift Enter, and I get a list, not just 10 numbers printed out, but this now has the structure in Mathematica of a list, and I am getting a list, starting off with an empty list, looping through, adding, using AppendTo to add to the list. If I were in JavaScript or something, this would be a push. I would be pushing an element onto an array, so I am pushing an element onto a list here. And then when I'm done my loop, I am printing my list, and it's showing me with the curly brackets to indicate that's its notation for indicating that this is not an individual thing, but it is this structure of a list with multiple parts. And it's a random thing, so I can get, different random lists of 10 random numbers between 1 and 10. Okay, that's what I wanted to show you. Thanks very much for your attention.